So just summarizing our 2025 plans, we want to make it really easy for Flutter to run everywhere. That means on Harmony OS, on LG TVs, on, say, a video game console. We want to no longer be the gatekeepers deciding which embedded platforms are sort of considered first class and supported. We want to make it possible for anybody to plug in. We're also focusing heavily on reducing the friction to access platform features. We want to get to a place where Apple releases a brand new version of iOS, and you can make calls directly into those native APIs the day they release it. You don't have to wait for, say, a plugin author to develop a package and distribute it and update it. You should just be able to call it directly right there. Hi, everyone. I'm John McCutchan. And I'm here today to talk about the state of Flutter. So, quick bio for those of you who are not familiar with me. I started working on the Dart virtual machine and programming language in 2012, where I focused on numeric computation performance, developer tools, and then ended up doing hot reload, which is a marquee feature of Flutter. Then I sort of went and did a side quest inside of Google, developed a new programming language for distributed systems, and ported web search to run on top of that. And now I'm back working on Flutter, and I lead the engineering of Flutter. So I'm going to sort of go over the last year, what we've accomplished, talk about what we're working on right now, and then talk about what's coming next year. So let's take a look back and see with some of the work that the Flutter project and community finished in 2024. Note that this isn't exhaustive, and so there's probably things that are really interesting that I forgot. So, go and check out the release notes for yourself. So, Impeller for iOS launched in 2023. And for those of you who are not familiar, Impeller is our new graphics engine. And it is now stable and performant on iOS. Impeller's critical features are that it provides predictable performance and leverages modern graphics APIs. It's a big step up from Skia, and I'll just quickly show a video comparing the startup performance. So on the left is Impeller, and on the right is Skia, and I will start Skia up here. And what we're going to see in this video is just janky startup under Skia and smooth startup under Impeller. So again, on the right here with Skia, you can see big spikes in frame times and hitches. And on the left, it's a much smoother process, and this is one of the benefits of Impeller. Okay, back to the presentation. So for iOS, the big thing in 2024 was that Impeller has stabilized and is used everywhere and has fantastic performance. We're also continuing to improve integration with iOS native features. So here's an example of text selection leading to a share action, which was recently added to Flutter. And then you can also write app extensions, iOS app extensions in Flutter now, as you can see in this screenshot. Text rendering fidelity has been improved in iOS and Android as well. You can see in the upper screenshot here that there's a kerning bug, meaning that there's a gap between the various letters. And in the bottom screenshot there with our fix, the kerning is corrected, and you can see that the characters are actually pushed together as they should. We've also made a bunch of changes to make sure that fonts render as close to native iOS would render the fonts as well. And so you can see sort of before and after here much closer. Flutter supports embedding platform views, which is if you want to take an iOS widget and put it inside of your Flutter app, you can do this similarly with an Android widget. You should think about things like Google Maps and WebView. These are very large, huge code bases that you're not going to port to a native Flutter implementation, but you can embed it inside of there. And so this year, performance of platform views on iOS has gotten a lot faster. It's nearly it takes 50% of the time on the GPU with our optimizations, and the frame times are about 33% faster than they were before. So what this means is things like Google Maps and ads are going to perform better inside of a Flutter app. Now, looking at Android, we've been busy developing Impeller for Android. We've also added support in Flutter for Android's predictive back gesture, as well as support for deep linking into Flutter apps on Android. Wanted to talk about one of the challenges that we faced last year for Flutter on Android. So in late November 2023, we started to get bug reports that Flutter apps would render all black, and it appeared to be only Samsung phones that were affected. We dug into it more and more, and it just looked like after your app is suspended and resumed, parts of the Android system just weren't functioning correctly, and frames were not being rendered, and it was very difficult to reproduce, and for a while it was specific to Samsung devices. We worked closely with Samsung to resolve it, and we thought that they had resolved the bug, but then we started to get more bug reports on non-Samsung devices. We started to get the same bug reports on Pixel devices, and so we started to get pretty concerned because this is not a great look for a Flutter app. If your user suspends it and resumes it and comes back blank, that's a terrible user experience. So shortly after we started to get reports of it happening on Pixel devices, we were able to root cause the issue and actually track it down to a specific commit that was made to Android in July of 2023. So you can sort of see like the commit was made in July, we get the first bug report in November, and then we start to get like better bug reports and better information in April. It's practically a year later after the bug was actually introduced into the system. We were able to release Flutter with a fix for this, and Android 15 does not have this bug. It's been fixed upstream. But this sort of highlights a challenge for the Flutter project, because Flutter is a platform, and it's our job to make sure that like any sort of bugs that are inside of Android or iOS that impact Flutter apps, that as a Flutter developer, you're insulated from this entirely. It's challenging specifically because the Android ecosystem is so heterogeneous. What we've discovered in this process is that release timelines of, say, Android 14 vary per vendor. Samsung actually released an Android 14 version before Google did, and that's why the first bug reports came in that it seemed to be a Samsung-specific bug, but it was actually a general bug. So, and then it gets even more complicated because let's say Samsung releases a point release for their Android 14, it's not known which patches are included, which bugs have been fixed, and it's sort of up to each vendor to like opt in and keep track of these things. So some vendors are going to ship an Android 14 version with this bug fixed, others will not, which means that Flutter has to assume that the bug is there. And unfortunately, we had to actually the fix for this bug in Android 14 actually required us to make Flutter's APIs more complicated, make the life of the developer, like the Flutter developer here, more complicated to work around this bug that only affects Android 14. This is just an example of some of the challenges that we faced, and you'd be surprised at how much engineering resources goes into making sure that we're stable and perform correctly on all versions of Android. So on the web, we've made a ton of progress. Flutter now can be compiled to WASM, and we're seeing on average a 2x speed up in your Flutter app when compiled to WASM versus being compiled to JavaScript. And sometimes it's 3 times as fast. So if you're deploying your Flutter app to the web, you really should be looking at the WASM deployment mode now. It's still a little early. It's not completely finished, but we're encouraging people to check it out. We've also been integrating into Chrome DevTools more to make the experience of developing a Flutter web app a little bit more, feel more native, like you're developing a regular web app. Now on to the Flutter Framework. So in 2024, one of the big changes is that material widgets are now default to the Material 3 specification. In the past, you would opt into this, and now we're pushing everyone into it. And this is just the latest iteration of the material design language and their specification on how widgets should be rendered. Has nice support for themes, and you give it a core color, we're able to generate light and dark themes and contrasting colors and things like that for you. There have also been many small features added to the framework. Too many to list here, but we've gotten scrolling improvements. We have adaptive widgets in Flutter. Historically, you've had to choose between material and say Cupertino widgets, and then write your app accordingly. Now we have adaptive widgets which will pick the right widget based on the platform that the app is being run on. And then we've made a bunch of improvements to like the tree view, the carousel, and we're particularly interested in improving the Cupertino widgets right now. And for those of you who aren't familiar with this, Cupertino widgets are what we call the iOS, the Flutter widgets that emulate native iOS widgets. We also made another release of the Flutter Casual Games Toolkit in 2024. And this year we added support for a new low latency, high performance sound engine and published a tutorial on how to build a word puzzle game with this toolkit. This toolkit's great if you want to make a simple card game or a simple word game. It has built-in leaderboards and monetization, and it's incredibly straightforward to build a small app, a small game, and get it into users' hands. And of course, you can deploy it on Android, iOS, and the web. So, summarizing 2024, we're sort of in the end game of Impeller, our new rendering engine, which is showing great performance in startup and in terms of frame times. We're investing heavily in WASM for the web. That seems to be the future and where we're headed. We are really focusing on platform fidelity, making sure that your app on iOS and Android feels and is indistinguishable from a native Android or iOS app. And then, of course, performance. Flutter's always cared a lot about performance, and we continue to iterate both in terms of GPU performance and CPU performance. So let's take a look at what we're up to now. I'll talk about some of the features that are just about to be released for Flutter. So on iOS, we've been staying up to date with the latest iOS and Xcode releases. Making sure that any new features that Apple introduces are like callable and available to Flutter apps. Now, probably a key thing that's going on in the next release is that we're finishing the migration to the Swift package manager, which is the new way of adding dependencies to various Swift packages in the Apple ecosystem. Flutter has now adopted this, so it's going to fit in and feel more like regular iOS development now. And one of the nice things about this is you no longer will need Ruby or CocoaPods to develop Flutter on macOS. And also, your pub package is going to start to be graded on whether or not it's been upgraded to support the Swift package manager. So please start upgrading your packages so you can get some points on pub. Looking at Android, we've added edge-to-edge mode for Flutter apps running on Android 15. And we've made tons of progress on Impeller on Android. So on the right-hand side, you can see the 99th percentile, the 90th, and the 50th percentile of frame rasterization times in the Flutter Gallery app, and the Flutter Gallery app is sort of a benchmark app that we use. So you can see that over the last year or so, we've gone from a worst case in the 40 milliseconds per frame, which is completely unacceptable, and now we're down under 20, which is approaching 60 hertz, which is where we want. And yeah, this is in the worst case frame time. The average case frame time, the 50th percentile, is very, very low, sub 10, so you're easily going to hit 120 hertz with Impeller. So the next release, Android will use Impeller by default if the phone supports Vulkan and fallback to Skia otherwise. Now, looking at the web, we have a new renderer here, Canvas Kit, which is coupled with our WASM story here. The legacy renderers have been deprecated. And we've been making a bunch of performance improvements. One specifically is that image decoding is now done on a background thread, which will help with startup time and avoid hitches when decoding images. We're also, of course, expanding on the WebAssembly support for Flutter on the web, as we see this is the long-term future for deployment of Flutter apps on the web. And now all first-party plugins and packages are compatible with WebAssembly, and we hope to see the communities move in this direction as well. So, looking at the framework, in the next release, we've been doing a lot of work to make Cupertino widgets look, as close to the real Apple widgets as possible. And there's, you can see on the slide here, there's tons of widgets that we've like gone in and made sure like match the native look and feel. We've also added wide color gamut support and color spaces to the framework, which is pretty great. So no longer are RGBA channels in Flutter restricted to 8 bits of precision. You now get full double precision. And on the slide here, you can see 2 different color spaces. In the orange triangle, this is the P3 color space. And in the white triangle, you have the sRGB color space. So now Flutter supports the P3 color space natively, and you can see that that gives you access to more colors. You can express things, colors with more precision than you could before. We've also been making a preview release of Flutter GPU, which is a new low-level library. You can think of it as something like WebGL or WebGPU. It's a cross-platform abstraction for writing 3D applications inside of Flutter. It's truly general purpose and can be used to build any 3D applications. Like you could build a 3D game or 3D model or whatever you want. It's pretty powerful. We also have a Flutter scene package, which provides a widget that you can then load a 3D model into. And you can see this demo here on the slide where, imagine you're trying to sell cars and you want to show the car as a 3D 3D model, and then allow the user to sort of configure it and play around with it. This is possible now with Flutter, and we're investing heavily in this as we go forward. Okay, so finally, I would like to spend some time talking about our plans for 2025. So the first thing that we're looking at is interoperability with native languages. Your Flutter app is written in Dart, but it's running on a platform that native applications are maybe written in Java or Kotlin or, Swift or Objective-C. And today, accessing these native APIs in Flutter is, painful, for lack of a better word. The programming model here is message passing based. So your Flutter app sends a message to another thread, which then decodes that message and then calls a native method, does some work and sends the response back. So the issues here are it's a forced asynchronous operation. You can't just synchronously call into some native code that you want to on the main thread. You lose type safety. If you need to refer to objects on either side of this message passing bridge, you have to use an integer to as an ID that then points into a map for the native object. You end up duplicating a lot of state back and forth between the 2 different languages. And then, of course, there's thread hops and lots of tedious boilerplate code that you have to write where you have to pack your message to send to the other thread and so on and so on. And so the reason why we have this complicated system is that historically Flutter has run the application on the Dart Flutter application on what we call the UI thread, which is a distinct thread from the platform's main thread. But most APIs on iOS and Android and other operating systems can only be called from that main thread. So one of the first things we're going to do in order to address this larger issue here is we're going to merge these 2 threads together. So the UI thread is going to become the main thread, which unlocks the ability to make synchronous calls directly into native APIs. Okay, but even with all the threads merged, it still is really awful. If you just think about all the boilerplate code you're going to have to write, right? If you want to call a Java function from Dart, you have to author a C function and have Dart call that C function, and then inside that C function, you're going to be making JNI calls so that you can invoke the Java code. So you end up writing a Dart function, a C function, and then the Java function that's being called. And most of that code is just unnecessary stuff that you don't actually want to have to type out. So in addition to merging the threads, we're also investing heavily in automatic language binding generation. So given any Java or Kotlin APIs or Swift or Objective-C APIs, you can use a tool that we will provide that will generate as idiomatic as possible Dart language bindings for these APIs. So you can see how once the threads are merged and once you have easy language bindings, the overhead of calling into some native code goes way down. And maybe you don't even want to invest in, say, a plugin, which is sort of the architecture today for how you would access native code. You might just inline it directly into your app. Okay, so But there's still one last piece to this larger puzzle here of making native interop really easy in Flutter apps. And that's like, what if you want to ship some native code alongside with your pub package? And this is actually going to be the common case, because if you think about, like, let's say you want to wrap SQLite in Dart. You don't want to have the user add a pub package dependency and then have the app fail to build because they have to go and download some binary release from an SQLite page. And then how do they even have the right, is it compiled for the architecture that you're deploying your app for? You're sort of like stuck behind this other project's build system. So the final piece to this puzzle here that we're working on 2025 is that the Dart project is actually going to enable us to ship and build native code as part of the building of your Flutter app. So if you have native code that you want to make available to Dart, you can sort of do it in a single pub package, and then your end user developers can just reference your pub package and everything will be built. And so once we have the threads merged, easy language bindings, and a simple way to build and distribute native code, it's a very different story than what we've had historically. Now, it's still not entirely, still some complications here, because they're native APIs, like a C API or Java API, often assume that you have a multi-threaded environment, meaning that you have multiple mutating threads running inside of a single heap, working together inside the program. This is not possible in Dart. We have a different concurrency model in Dart, the isolate model, and it's message passing based. But we are planning on adding, at least in a limited capacity initially, full multi-threaded shared memory support to the Dart programming language. So we'll add mutexes and locks, and you'll be able to have concurrent threads accessing the same data. We're going to do it piecemeal, and the first step will be what is necessary in order to support common APIs on Android and iOS. It won't be the full-fledged multi-threaded concurrency, but that's the direction that the project is headed in. Another area that we're looking at in 2025 is integration testing. So almost all large-scale Flutter apps involve using native features, a lot of apps will embed a platform, like a platform view of, say, the web view, or will want to request a permission from the user so that the app can access the camera. And Flutter's done a great job of giving you a platform where you can write your app in Flutter, in Dart, and it's going to run on iOS and Android. Unfortunately, we didn't take it all the way and actually make it possible for you to be able to write tests that test these native features. So we're going to, we sort of consider these things as core missing features from our integration test package. And so this year we're going to focus on making it possible from an integration test to be able to say test notifications, ask the user to approve a permissions prompt, and then have the test say, yes, approve that prompt, and then validate that your application behaves correctly in that state. As well as permission dialogues, and what if a platform view is a core part of your app, and part of the testing that you want to do involves clicking on something inside of that platform view. You can't do that today in Flutter, but we're going to make it possible. And then finally, taking a screenshot of your entire app and doing golden screenshot tests in Flutter when it involves native features is problematic and buggy, and we're sort of resolving that. So you can expect in the near future to have a very straightforward way of testing these aspects of the native parts of your Flutter app. And perhaps in the future we'll expand upon this, but these seem to be the most important critical features that we need for testing. And also we, the Flutter team, we need the ability to write tests of this type as well. We currently, if you want to write a test that says I have an Android platform view and it renders correctly, that's an incredibly tedious, toil-filled process, and we want to get it down to where you can write, say, a 20-line Dart function that does it all. Last year, we spent a lot of work improving platform views on iOS, and this year we're going to be, into 2024 and 2025, we'll be investing heavily in the Android platform view space. So right now, Android has 3 different platform view implementations, Each implementation has different trade-offs related to performance and compatibility, and unfortunately, from my point of view, we've pushed this complexity onto you, the developer, and so you have to sort of choose wisely because different platform views will give you very different performance or compatibility, and it's just too much complexity that we're like forcing on our end users. And funnily enough, we were explaining our different implementations of platform views to the Android team recently, and one of the engineers in the room was like, hold on, that should not be possible. And then they flagged one of our 3 implementations as like, this is a security privacy bug, and that will be fixed in Android 15. And so one of our 3 implementations will just no longer function. But we've been working closely with the Android team to get new APIs added to the Android platform so that we can have sort of one robust, simple way to embed Android views inside of your Flutter application that give you good performance as well as good compatibility. So finally, one of the big things that we're looking at in 2025 is pluggable platforms. So today, Flutter Engine has a bunch of platform-specific code baked into it, like Android and iOS is like written directly inside of the Flutter Engine repository. And similarly, Flutter Tool has a lot of baked-in knowledge about iOS and Android. It knows how to invoke ADB, it knows how to run Gradle, it knows how to run Xcode build. You know, you type Flutter build, and internally we have a bunch of code that we've written that invokes the native build systems. So supporting, if you wanted, let's say you wanted to add support for a new platform, like recently LG announced that all of the UI on LG televisions will be written in Flutter. But like LG has their own proprietary way of rendering graphics on their televisions, and so we can't add support for that type of rendering into the Flutter Engine repository itself. So we sort of need to evolve to this place where Flutter is everywhere, and we need to make it easier for third-party platform vendors to distribute their, like, you know, the compiled bits that you need and the toolchain knowledge outside of our tree. So today, like, we ship Flutter Engine and it comes with iOS and Android built in. We've shipped Flutter Tool. It comes with iOS and Android built in. Where we would like to go is that, like, these platforms are not part of Flutter Engine. They're not part of Flutter Tool. They're actually like things that are separate and distributed separately. So like imagine, like, what if supported platforms in Flutter were distributed as pub packages? And what if iOS and Android weren't special cases inside of the Flutter code base? We plan on tackling these issues in 2025. And I think it's really exciting because you see, like, it's not just a theoretical problem. I think in the past it sort of was, but now it's like you have LG, Samsung, Shorebird is essentially its own embedder. And more people, more and more like companies seem to be adopting Flutter as a platform, and so we want to make it really easy so that you don't have to like fork Flutter Engine, and then sort of deal with all that toil work of keeping your forks up to date with upstream Flutter. So just summarizing our 2025 plans, we want to make it really easy for Flutter to run everywhere. That means on Harmony OS, on LG TVs, on, say, a video game console. We want to no longer be the gatekeepers deciding which embedded platforms are sort of considered first class and supported. We want to make it possible for anybody to plug in. We're also focusing heavily on reducing the friction to access platform features. We want to get to a place where Apple releases a brand new version of iOS, and you can make calls directly into those native APIs the day they release it. You don't have to wait for, say, a plugin author to develop a package and distribute it and update it. You should just be able to call it directly right there. Questions, and thank you all.